The broadcast is now starting. All attendees are in listen-only mode.
Oh boy, okay. There you go. Okay. All right. Bye-bye. All right. Just a test, Fred. You can see my screen and you can hear me.
Yep.
All right, great. Okay. Thanks everyone who for your interest today. For those in the media that we sent out a webinar, we had a webinar earlier this morning that talked about convective evolution. For today's event, this is June 3rd, 2020. And this is really in lieu of some of the recent discussions we've had at our virtual media workshop, which we held last month in May. So with that, I've got Fred McMullen here with me today. We are both teleworking, and we are going to talk about today's potential severe event across the Pittsburgh forecast area. So I will go ahead and turn it over to Fred, who will begin.
Yeah, good afternoon, good morning, everybody. Again, thanks for tuning in. So what we have here is the HREF calibrated severe threat for wind. This is used as a tool by SPC forecasters, and I have a table below here to kind of identify what the criteria is for shading and for contouring for the field. And you can see, so for wind, this is updraft helicity greater than 75 meters squared per second squared, and CAPE and effective shear critical thresholds. Then also I have on the background is updraft helicity. So something that, I want to reiterate that updraft helicity, if you see it, does not automatically mean there's going to be tornadoes. We learned this from the Nashville event that happened earlier this year. But again, it just shows that the potential where the convective allowing model is outputting rotating updrafts. And so these are all the dots and the shadings in the background. The other lines on here, the yellow and the orange, are the Storm Prediction Center's convective outlooks as of 7Z this morning. And it kind of shows you the enhanced risk across eastern PA. But I guess the main message from this to take away is that the brown shading is the convective wind threat based on the SREF calibrated wind severe, and which aligns pretty nicely with SPC's outlooks. These are tools that are available on their webpage that you can use to help discern, wind threat and also hail and tornado as well. We'll go to the next thing. We'll turn it back over to Miranda.
Okay, thanks, Fred. So like Fred said, everything that we're showing you today is sort of a glimpse into what we look at when we're anticipating an event. One of those is the sounding, which this is the 12Z sounding out of Pittsburgh from earlier this morning. There are a few variables or parameters that I'd like to point out. And really, sounding analysis is a practice skill. It's a great skill to have if you are interested in becoming, a real in-depth forecaster, or this interests you. Soundings really can tell a lot about what we can expect in terms of potential hazards, whether or not our instability is surface-based or elevated, what our potential tornado threat might be. Are we dealing with a damaging wind threat as well? So you can really get a lot of information, and I'm even learning more about what I can get from some of these parameters here across the bottom part of the screen. But I'll just briefly talk to what we're seeing from the 12Z sounding this morning. And I mentioned an inversion or elevated instability, and you can tell that based on what is happening here as we get closer to the surface, or this is kind of our boundary layer is what we like to call it. You can see we have this warm nose of air that would be indicative of maybe a low-level jet across the region. And what that's doing is it's not allowing our instability to be surface-based. So instability would be this measure of what we call CAPE, convective available potential energy, and that is outlined here in this dashed line, kind of just to the right of our temperature profile. So we have what we call an EML, and that's what I have here on the left part of the screen. That's an elevated mix layer. You'll probably see that in some of our discussions. We talked about this in our virtual media workshop when we discussed the April 7th and 8th QLCS event that occurred that brought a ton of severe weather across our region. But nonetheless, you're looking at steep lapse rates to allow that convective available potential energy to be evident. As of this morning, it was elevated, or it is elevated. One other note that you want to look at too is you want to kind of look at your wind field. So you want to look at the height of your convection, which would be kind of where your CAPE, as far high as it goes, which is about 200 millibars here. So you would visualize this to be your updraft strength and height, given all things considered. I mean, there could be fast shear or whatnot that could help kind of shear the storm apart aloft, but nonetheless, this is what you are working with this morning. So when we look at our storm motion, and when we're anticipating storm motion, you would want to look at the mean wind flow through that unstable layer to get a eyeball understanding of the speed as well as the direction of the storm movement. So you can see most of our wind is oriented from the west-northwest. So that would indicate we'd have east-southeast moving cells. You can also see that here in the hodograph. This hodograph from 12Z is a little messy. Perhaps as the balloon went a little bit more aloft, it got caught up in some sort of updraft, or maybe even the precipitation that was evident to the northeast of us. But nonetheless, you would look at your 0 to 6 kilometer shear vector, in which is basically, so the 0 stands for the surface, 0, and then as we go up, we have 1 kilometer, 3 kilometer, 4, 5, and so on. And you would look at that average vector to denote where your storm motion would be. And that is really what's indicated here by this beige box. So we are anticipating storm movement to be to the east-southeast given our wind profile, or our mean wind up through our unstable layers. Something else that I'm looking at this point down here in the lower left is another indication that we are elevated in terms of our instabilities, because we have 0 surface-based CAPE. So in order to find the CAPE, we actually have to look at our most unstable, or mu CAPE as we call it, which is just shy of 1,000 joules per kilogram. So there is instability aloft, and we did see that as we did issue a severe thunderstorm warning earlier this morning to the northeast around the Du Bois area, as that convective complex just skirted our forecast area. Now we'll take it to pivotal weather, because I know a lot of you either use BuffKit or maybe pivotal weather, as that is publicly available, and they do a really great job at showing forecast soundings. This is for the NAM 3 kilometer at 21Z over Allegheny County. We like to use the NAM in our office as sort of a worst case type analysis of what we can expect, because the NAM tends to have a higher moisture bias. So you can see at the surface, it's anticipating a 72-degree dew point at 21Z. Now, I don't believe that'll happen. That seems a little high. Fred and I were discussing earlier, but nonetheless, it gives you a good sense of what the atmosphere is potentially capable of. But you would want to take this information with a grain of salt, just given the different biases with the models. The best advice we could give is to take a look at your surface observations, or what's going on currently, and see, or maybe what the actual derived sounding was out of Pittsburgh that we launched each morning and evening, and see how well that pairs up with what the models are showing. And so when you can find a model that has a good pairing, then maybe you can put a little bit more faith into it. So I talked a little bit about storm motion. We talked about that on the earlier slide. We still are anticipating a southeast or an east-southeast movement based on our wind field, and also looking at our 0 to 6 kilometer wind shear vector. If you notice though, by this afternoon, the instability becomes surface-based, and we know that because our updraft height is much lower than the earlier sounding, and our CAPE is pretty much right at the surface. So that's what we mean when we say surface-based CAPE. The NAM 3 kilometer wants to put over 4,000 joules per kilogram of CAPE across our area, surface-based CAPE, for this afternoon. Now, I said take what the NAM says with a grain of salt, just based on the moisture bias, because more moisture will tend to lend towards higher CAPE values. But nonetheless, you can see we've got deep convection all the way through our column basically this afternoon, whether that be 4,000 or 3,000. We also look for the hail growth zone, which is outlined here in these blue dotted lines. Oh, I'm sorry. It is not outlined in these blue dotted lines. It is from -10 Celsius over to -30 Celsius. So these two lines here, what you're going to want to look for when you're looking for the hail growth zone. But the main point here is we have the deep convection that goes through the hail growth zone. So our hail growth zone is actually at the midway point of our convection. That would tell us that if these storms can get high enough based on the shear balance, we could see the potential for some larger hail. We also are looking at a wind threat today. As most of you know, you probably noticed that it was breezy this morning when that first disturbance came by, and there's a lot of wind aloft. There's a low level wind shear concern from an aviation standpoint as well, and what that tells you is there's just a lot going on across the low to mid levels and upper levels as well. So we would anticipate a wind threat. Now, we normally look at DCAPE, and just given the NAM's moisture bias, we don't see much in terms of dry air. And DCAPE is actually a parameter that you can find, and I want to show this morning's DCAPE values at over 1,000 joules per kilogram. So when we talked about this in our virtual media workshop, we said to look for these pockets of dry air within your temperature and dew point spread. But based on this 12Z sounding, you really wouldn't think that there's a whole lot of dry air to work with, which is why it's important to look down actually at your calculated values. So over 1,000 joules per kilogram of DCAPE is actually a very good amount of dry air aloft that can be mixed down. So strong wind is definitely a concern for this evening, or for this afternoon and this evening. In terms of tornadoes, you know, with QLCS events or clusters of storms or maybe discrete cells out ahead of a storm, you want to watch for the potential for tornado threat. But when is it a good atmosphere for that? Well, you want to look at your Hodograph, and a lot of people say that Hodographs makes them nervous, and I am one included within that group, and I'm trying to do better at looking more at Hodographs because they can tell a lot of information about the vorticity available in the atmosphere. And so what we look at is here, and this is what I like about pivotal weather, is they actually calculate what's called this critical angle. And this is what we would look for when we're trying to discern whether or not streamwise vorticity has the potential to be ingested into a storm, or whether it's crosswise, which would be working against a storm, which would then kind of deter any tornado genesis type possibility. So for this, just a quick glance, you would want to look at your storm motion. For us, it's going to be this beige box, but pivotal weather looks like they're taking sort of the best case scenario for the potential of tornadoes, and they're taking that location and they're drawing it back to the start of the Hodograph. So that's kind of the storm vector there, and then they're looking at that angle between where our storm vector is and the start of the Hodograph from 0 to 1 kilometers there. So this angle is 33 degrees. So the closer to 90 degrees that we get, the greater chances for streamwise vorticity to be ingested. That's what we want when we're looking for the potential for tornadoes. Closer to 0 would mean crosswise vorticity, which would not be good for tornado development. This slide here, I just want to leave it here. If you want to practice this at home, you can do so. It's from our Science and Operations Officer, Matthew Kramer. He put this together and presents it to us every season just to get us back in the game in terms of severe weather. So I'll leave this here. If you want to do this on your own or get better with Hodographs, of course, you can always reach out to us and ask us for help if you have the questions. But one good thing about pivotal weather, keep in mind, is it does provide this critical angle so you can kind of see the best case scenario. So based on what we're seeing here with the Hodograph, we would not anticipate a large tornado threat, but we also wouldn't minimize that threat either. You can also look at 0 to 3 kilometer storm relative helicity to help with your understanding of what's going on. And that is one of the parameters that is calculated for you down in the sounding analysis and forecast sounding analysis. So what you want to look for is values from 0 to 1 kilometers to be greater than 100. And for surface to 3 kilometers, you would look for values greater than 250. So we're just shy, especially the 0 to 1, but then a little bit more shy on that surface to 3 kilometer threshold from what the SPC discerns as a good tornado threat. But we're also not 0, and you see that here with the analogs that shows that there have been weak matches with some tornado events from supercells given the Hodograph and what it looks like, as well as significant hail events too. In fact, more so on the hail side than on the tornado side. I'll pass it over to Fred to talk about DCAPE.
Yeah, thanks, thanks, Miranda. Yeah, so this is something else that we covered in the media workshop earlier this month. This is used to kind of assess the DCAPE potential and how strong the cold pools will be with storms that produce, strong outflow boundaries that can, initiate more storms or could lead to the potential weakening if the boundaries get too far ahead of the main cells. But this is available on BuffKit. This is from the 6Z NAM for the wheeling area, and this is the time height starting at the bottom. It goes from right to left. And you can see you get there from the overview section, then you click on surface delta Theta-e, and this is a good way to kind of see drier mid levels, and then also the potential for downbursts. And what happens is when we see areas that are in red, and that's usually a delta Theta-e of about 20 and or greater, BuffKit shades it in red, so -20, -30 are really good parameters. We know that if we get an icy core, and when we say icy core, we mean 50 dBz of a storm into this layer, which is ideally we like to have around 15,000 feet. That leads potential for downburst. So if we see the conditions are favorable for downburst, and we get icy cores into this level of red, then that could lead to severe thunderstorm warnings. So again, an operational usage of this in real time. Next slide. And then also, of course, on SPC's page or Mesanalysis page, again, it's a great utility use. This is a DCAPE parameter that's available. This is the WRAP forecast valid at 2 p.m. this afternoon. Again, showing larger DCAPE values across lower Michigan. Again, ideally, a trigger number for us is around 600 when we have the potential for downburst. So looking at this chart here, the potential for downburst based on the WRAP analysis will be more out there towards eastern Ohio, southwestern Pennsylvania. But as we go through the afternoon, I'm sure these values will increase and spread eastward. Next slide. The CIPS analog produced by the St. Louis University is a great tool as well. So it looks back at previous analogs, essentially the top 15 best matches to this severe weather event, and it produced these gridded data sets. So the left image talks about the probability of at least one severe weather report. Now remember, with analogs, you're not going to see these 80, 90%. Very rarely will you see those. Most of the time, if you get above 50, that's a strong signal. And in this case, we have 60 to 70% probability right along the Ohio River, northeast Ohio, northwest PA, western PA, for at least one severe weather report within 110 kilometers of a grid point. Then we go to the right image, and the right image indicates the probability of seeing 5 or more severe weather reports within 110 kilometers of a grid point. And again, this area pegs just east of Youngstown with a 50% chance of seeing 5 or more severe weather reports. So this kind of gives us an idea and a signal that, hey, looks like we'll probably see a severe weather report at a minimum. And, it also indicates that the potential is there for, multiple reports to come in as this event unfolds. So we'll go to the next slide. And then also that we're also concerned with, as we are with every event, is flash flooding. So flash flooding is not as cool as severe weather for meteorologists, but again, it's the biggest impact that we have. It's where we lose most lives in this region. And so this is the right image. I'll start with that. That's the Weather Prediction Center's Day 1 excessive rainfall outlook. Again, I encourage you all to look at that on their webpage. They do a great job with discussion outlining heavy rain threats and some of the science that goes behind that. Again, this has been very consistent since Monday with a elongated area from the Midwest the whole way to the Jersey Shore. Then the left image is off the 10Z HER for Pittsburgh, and this is from BuffKit, and this is under the heavy precipitation tab. And what's cool about this is that these are color coded, so it already has built-in trigger thresholds for you. So yellow means caution, red is bad. And you can see at this point, again, warm cloud depths over 11,000 feet, we get concerned for almost like a tropical rain process with collision coalescence with supercooled liquid water. Again, PW, 1.58. Again, not really reaching the threshold yet, but you take the P watt and the RH together, and you get a value about 1.3. So again, in the caution stage, it also has vectors. The vector that we're kind of the most concerned with, in terms of us, is if we see these arrows that are very small, that means back-building storms. If we see these arrows parallel, then that could be the potential for training. So right now we have a southeast movement denoted by the blue arrow. That's a cloud layer mean movement. So one of the things that we'll watch out for today is that if we have train of storms, that could lead to flash flooding because they're kind of moving on an east-southeast orientation. And we're not worried about back building. Again, overall it's been dry the last 7 days. We're somewhere around 40 to 60% below normal for the last 7 days, so our ground's very dry. We can hold a lot of rain. That's outside urban areas, cities, where it only takes 3/4 of an inch in 1 hour to cause flash flooding, and that's not much when you have PWatts going towards 1.7, 1.8 later this afternoon. And I think that's it, Miranda, correct?
Yeah, that's all. I think I'll just end my thoughts with saying, if you do have BuffKit, make sure you look at every point available to get a big picture view of what's going on, because maybe a wind threat here might not necessarily be a wind threat somewhere to the east of us or south of us. We've got a lot of stuff that goes on across, southwest Pennsylvania, eastern Ohio, northern West Virginia, a lot of terrain involvement, you name it. This is kind of an interesting place to forecast for. So don't just hone in on one model, and don't just hone in on one point. Make sure you get a big picture view. And if Fred, you don't have anything else, we'll go ahead and end this webinar. We will send this out along with the links, as Fred mentioned, to all of the products that we're showing here in the presentation. And if you have any questions, please feel free to reach out to us. Thanks.